This is take 2. You don't know that, though, unless I just told you. Been a while since my last upload. It's just been a lack of stuff to talk about, but I've done something pretty cool this time. I made something that I call YoCad. You can't see it right now, hang on. YoCad. And YoCad is just what it sounds like. It's a CAD tool slash software that I designed specifically to make yo-yos, and that's not out of more work than just making a general purpose one. It's because it has a lot of stuff pre-programmed, pre-built into it. And let me just show you exactly what I mean. So this is a CAD software that's run like it's 1980 effectively, where you tweak text files. Literally, you tweak these text files, just 4 of them, and it will design the whole yo-yo for you. And let me just show you what exactly I mean. Really? You didn't? Okay. Kind of baffles me how that doesn't work. Anyway, let's pull these into each other here. Oh, whatever. It's, I'm just gonna open them up here in my handy dandy little text editor. Okay, so this is the main body of it. Specs. Bearing type, that's type 3. So there's type A, B, C. This is a type C bearing. Oh, whoop, you still can't see this properly. There we go. All right, bearing type. So there's 1A, 2B, 3C. Type C bearing, diameter 55. It's clearly in millimeters. All yo-yo designs in millimeters, right? Width 44 millimeters, mass 65.5, axle length. I'm gonna need that later. I haven't implemented that yet. Axle unit type, 1 is metric, 2 is inches, or at least that's the plan. All this stuff is tentative. I have it updated on GitHub. The README is a little out of date now, mainly because I put in like 10 hours of work on this today, procrastinating for other stuff I need to do. But anyway, pilot hole diameter. That's also for the axle. I didn't want to be able to have a chart. I didn't want to hard code a tap and thread chart into this, so I'm just forcing the inconvenience onto the end user, I guess. And then that's the density. That's approximately aluminum, and that's easy. Cup. Okay. Let me explain to you what exactly all these coordinates are. You're like, Zach, you want to design a yo-yo off of less than 15 numbers or pairs of numbers? That's crazy. How are you going to do that? Well, I'll show you. Oh, whoop, wrong one. Sorry. Ta-da. Holy crap, that was easy. And this yo-yo doesn't look particularly good, but look at that. You typed in you made 4 text files, and then it spits out a PNG, a graphic, a little image that shows you the design. And it uses something called Bezier splines. It's these red dots here. That's what you entered the coordinates for. They're the control points of the Bezier spline. And by changing what those are, you can change the geometry. And here's why this would have been a lot easier if I didn't do it this way. But just to prove that this is actually a pretty dynamic piece of code, watch this. See that? You can just delete points too. You can give more information or less information, and it will still plot. And so effectively, this does this, then it runs math on it. It performs numerical integration, revolving it around the center, and it calculates what the mass of it's going to be, and it calculates where the, not center of mass, that should say center of area is going to be. I'm going to make it show up like a cross on there. And then it spits out the rim weight ratio, which is a really important number I talk about in my yo-yo design tutorial videos. And so you just tweak these values in these 4 text files, but it's not perfect yet. What do I mean? I mean that you need to make sure that the first value in, or rather that the last value in your bearing coordinates document, this one right here, these are on the C size bearing that you specified in your specs document right here, type 3 is type C. The last number here, that's the coordinate value that you're at on the plot, and you need to end your bearing there, meaning you need to start your profile there. And you can just intentionally break this whole thing by just not having that first value here and the last value here be the same. And that's true for everything. The last value of profile needs to be the first value of rim. The last value of rim needs to be the first value of cup, and it is, oh, hold on. Ooh, I don't think it is. Is this broken right now? Maybe. I don't know. Sorry, I'm still, as you can painfully tell, it's still a work in progress. Wait, so it ends at 19. Oh, maybe. It ends at 22, 25. Oh, right, I should be going off rim and cup. Yeah. It ends at 22, 25. This is fine, actually. That works pretty well. Anyway, the it works. Everything, or at least it works right now. You can break this, you can make it not work, you can make it, it'll still graph something, but it will either, if it doesn't look wrong, it could be, and its numbers will be imaginary. So you got to be really careful with it. Obviously the next thing to do in this, I want to add a GUI to it. I want to make it spit out error messages. I want to make it calculate minimum wall thickness. I want to make it calculate minimum draft angle to make sure everything is machinable. But yeah, I want to make this a tool specifically designed to make it as easy as possible to design a yo-yo. That's why I made this in Python. It's free on GitHub. I'm not going to say the name of the repo out loud right now. I'll post this and all the information in the description, I think. But yeah, this is YoCad. This is what I've been working on for the last week or so. That sound okay. I'm gonna be working on it for a lot longer, but I got it to a minimum viable product. I got it to spit out. Oh, I haven't told you about the coolest thing yet. Sorry, the downside of multiple takes. Sure, it may spit out and save a figure, but it also makes the CAD file. And that is the truly impressive thing. Anyone can design a yo-yo. You can design a yo-yo by drawing on graph paper. This also makes the CAD file. You can just send this to a machinist, tell them what it is, tell them this is a quarter section, and they will make it. It's that easy. All for free, all in 4 text files. And that's what I was going for. But anyway, it's just a bunch of short Python functions I wrote. Okay, some shorter than others. If anyone here is a computer scientist or anyone watching this, it's not well written. I mean, I made this is actually the second iteration of this. I made this whole thing in Fortran 77 first, and it worked. It worked shockingly well. But now I made it in Python, and I got it to export the DXF file. That's the hugest deliverable. That's where most of my time went, getting it to spit this out properly. And yeah, I'm gonna release this in some primitive form relatively soon. Well, soon with respect to what? You guys don't know when. Yes, you do. Not soon with respect to when I record this video. Hopefully I edit this, spend some time editing this, do some other stuff, and then I get it out. But yeah, yeah. This is YoCad. Hope you like it.